So the next standard that IEEE is developing is called ZigBee, and this is designed for very, very low power, very low data rate monitoring, as we call it sensor networks. This is the sensor network protocol. Some of you are working on sensor networks, so this is the protocol most of these modes and other things use, ZigBee. So here the key thing is the power, because they want the batteries to last for years in these sensors. The duty cycle, most of these nodes are mostly sleeping. So the duty cycle is less than 1%. And it can also be used, when we say sensors, it can be used for wireless light switches, meter reading, and patient monitoring. So wireless light switches means that you go back into the room, somebody senses that, or some device senses that you are in the room and the light comes on. Right? That's a sensor. Meter reading, the car passes by on the road and they read your electric meter. Patient monitoring, when if a patient is wearing some kind of device at home, and if something happens to them, they fall down, the device tells the doctor, or calls 911 or calls the hospital or whatever. So these are the low power consumption applications. So this has been standardized 2006. So it has a very simplified protocol compared to Bluetooth. As you can see, the Bluetooth has 250 kilobytes of code, whereas this one has only 32 kilobytes of code. And on the other side, it actually covers a longer distance and more nodes simply by sleeping more. So the key is that most of the time, most of the nodes are sleeping and they wake up rarely. So there are three bands in which these networks can operate. 2.4 gigahertz band, as usual we know. 915 megahertz band, that is also usual ISM band, they call it. ISM is the instrumentation, scientific and medical. So that is the band that is designed for scientific use, and that's what we use for 11, Bluetooth, and here as well. And then 915 is also another ISM band which is also used in, actually I think there was an 11 working in this band. We don't use it that much, but many of the phones use 900 megahertz, cardless phones. And then in Europe they have given in 860 megahertz band one channel at that one. So there are channels like that which are dependent upon the countries and so on and so forth, but this is the fourth, as you can see, this is the fourth personal area network standard, and the industry group that supports it called ZigBee Alliance. This is an IEEE standard, but ZigBee Alliance is the one that works after the IEEE. All right, next, so what is new in ZigBee? ZigBee allows the original Bluetooth configuration where you have a central device and then many of these, so we call it master and the slaves. But it also allows mesh configuration. And mesh in the sense that if this device wanted to talk to some other device, it could go through multi-hop, could go multiple hops. And that's the new thing about this one. And therefore, there are three kinds of devices. One is what we call full function devices, and another one is reduced function devices, two kinds of devices. And the full function devices can actually become a PAN coordinator. So this is the master. So the full function devices can become a master, and the reduced function devices will remain slaves. All right, not every device has to become a master. So here, these are full function devices, but this is the coordinator. So they will select a coordinator among themselves, and that will become the master. and if the master goes away, obviously they will re-elect somebody else, or there is always a standby monitor which keeps track of the same thing. So all that is done as a standard way. And these green things are reduced function devices. They cannot become a master, and they will not participate in that election, but they will just obey whoever becomes the master. So that's all we are going to say actually about this ZigBee thing. The key idea is that it allows mesh topology, and with a lot more sleeping. So 15, if you want to see the whole picture, has many parts. So there is 11, 15.1, 15.2, 15.3, 4, 5, 6, and 7. And so the 1 is the Bluetooth. 3 was for, before I come to 2, 3 was for that ultra wideband, high speed, and that was disbanded. Actually, disbanded means that 3 was divided into many groups, 3A, 3B, 3C, and so on and so forth. 3A was working on that ultra wideband, and those were the two groups which fought, and then they disbanded. But so 1 is the Bluetooth, 3 is originally ultra wideband, and then finally ended up developing something called millimeter wave, 3C. And so we have, I think we have a slide on 3C right here next after this. And then 4 is the low rate, and this is what ended up developing the ZigBee. And it has many different groups such as 4, 4A, 4B, 4C, 4D, 4E, and for different applications. But most important of these is ZigBee, which is what we discussed here. And here, moving on, we have 5, which is mesh. I think the result of that probably we are moved into ZigBee, applied into ZigBee. 6 is the body area networks, and 7 is the visible light communication. So millimeter wave actually is 3C, and millimeter means 60 gigahertz and up. So remember, we have microwaves. Microwaves are 2.4 gigahertz, right? The millimeter waves are 60 gigahertz and up. So FCC allocated 9 gigahertz in that band for general use. Okay, and so if you take a OFDM approach for 9 gigahertz, you can get lots of bits, very high speed. And so that is what is being used for wireless gigabit. Basically, what is going to happen soon is that your television and your DVD player and other entertainment devices, DVR, they will be talking digitally, wirelessly, at a very high speed to each other. For very short distances though, it's not going to go 2 kilometers. It's just for a few meters. So that's why it is in the PAN, personal area network. And they are going to use 60 gigahertz band, this millimeter band. So this design is for that application, is for connecting your HDTV servers and HDTV devices. So let's see. License based on interference protection on a link by link basis for outdoor use. So there are 2 applications of this band. One is inside, which I just described to you, is where you keep within a few meters, and then you have very high speed communication. This is like HDTV cable replacement. But there's another application where you go between 2 buildings. So if we could have, for example, a link between here and our department building, generally less than a kilometer or so, but very high speed connection, wireless. And so that one requires a license, because if everybody starts using outside for longer distances, then they can start colliding. But license is free. This is free, but on a registration basis. So this is where you you say, well, I'm going to install this link, and then you get the license, and then somebody else cannot block it anymore. And they will have to, if they want to install something, they will have to install it such that they don't interfere with what is already given. So no license required for indoor use. Can send multi-gigabits over short distances, and that is what is being used for wireless gigabit. And so this is for cable replacement, HDTV server, and so on and so forth. This has been published as 82.15.3.3 2009. So this actually, as we said, has two different applications. One is the personal area network. Another one is actually more like I would call enterprise networks or metropolitan networks. That is not being standardized here. This is the 3C is for personal area, and this is for the inter-device communication. Next thing is body area network. So what is a body area network? Basically, we are going to have so many wireless devices on our self that people felt that there is a whole new area that we need to develop. So for example, you could have a wireless, you could have a display, you could have a heart monitor, you could have a phone, and so on and so forth. So many things on your body, right? Some inside the body, some outside the body. And so Microsoft actually got the first patent on this in 2004. And that started this whole field. Now some of this is wireless communication, some of this is not wireless communication. For example, when we say body area network, it also means that the hard device is talking to the outside monitor using some kind of nerve transmission. Okay, so the transmission could be body through body as well, which could be just some body parts rather than wireless. Could be body fluid, so on and so forth. So that's a very new area. There is not much to say about it, but this is a new area developing in this, and IEEE has formed this new group, which is still working on it. And then after that, they formed this visible light communication, which actually I haven't prepared the slide on, but visual light communication would be very similar to this 60 gigahertz band outside use, where if you wanted to do outside, you could get very high speed communication using optical kind of communication. All right, so that brings us to the end of this personal area network, and the 5 key points are that impulses in time domain result in very wide frequency spectrum, and that was the beginning of UWB but not the end, because in the end that did not survive. UWB communication today is done using what? OFDM, which has nothing to do with the pulse business at all. With UWB, in either case the power is below the noise level, and therefore it shares the spectrum with current spectrum users. So when we do UWB transmission, we are interfering with everybody. We are using all the spectrum that people are using for anything else, your television, your wireless, and everything else. But this is all below the noise level, and therefore it's allowed. Third thing is ZigBee. ZigBee allows 20, 40, and 250 kilobits communication by using all those different channels that we talked about at different kilohertz. And but it allows mesh. That's the most important thing, is that it allows a mesh mode where you can go longer distances by going hop by hop. Millimeter waves gives you very high speed multi-gigabit for short distances using a lot of spectrum, and then the body area networks allows a low power communication around the living body. All of these are very well described on Wikipedia. And in addition, I have prepared a list which is put here on this URL, which gives you some additional reading material on these topics. Okay. ZigBee Alliance is another place for finding more about ZigBee. Many of these books which talk about WPAN